So I hope you can see me clearly. I hope you can see clearly from here. This is Easy Science TV. So we are going to be focusing on some key areas today. So the major thing we are going to be looking at today is what we call the 5 strategies or 5 tricks that is used by the top scorers in doing so well in their examinations. So we are going to be looking at these 5 tricks, and I do hope that in today's lesson you are going to be a key beneficiary. So our hope is to ensure that every student does extremely well in the forthcoming examination. So that is why we have come in this method, to make sure that we teach everybody, we expose the weakness of JAMB to you so that you can take advantage of that to succeed in a very extremely flying manner. So that is why we are looking at these tricks today. So we are looking at the first trick here, which is the vanishing trick. We apply these tricks in matrices, and we also apply it in number bases. So I'm going to teach us how to apply these tricks today. But before then, I want to be sure that we are very much available and that we are up to some very wonderful numbers, so that I don't have to be talking to myself. If you know you are with me and you are ready for JAMB 2026, please just type in the comment section below. Remember that in this live chat, there is no special place for chat. All right, so there's no special place for chat. What we have is just the normal, usual hashtag chat area. Okay, so if you have any question to ask, just put it in the chat, the normal chat. Bring in hashtag, then go ahead and type whatever you want to. I will be more than ready to answer all your questions, right? So remember, it is JAMB and not any other exam. I'm not saying you can't use it in any other exam, but for JAMB, you need these tricks to save your time, increase your accuracy or speed level, and finish with courage and without any fear. So this is where we are going to begin. Welcome to Easy Science TV. If this is what interests you so much, don't forget to leave a like and share to others. All right, and also do well to subscribe if you are new to this channel. But before then, let us continue, so don't waste much time. The vanishing trick is the first trick we are going to deal with. So how do we apply this trick? We are going to look at this trick. Remember, here we are 1 0 1 0 0 1 in base 2. Yes, the vanishing trick is a tricky method that you are going to apply in the forthcoming JAMB examination to save your time. In this vanishing trick, wherever we have zeros, this base we hibernate. What do you call hibernation? Okay, it will appear as if it does not exist. Okay, it will disappear right here. It's called this disappearing method or the vanishing trick. Then when it comes here, the 2 will appear again. When it comes here, it will disappear. And when it comes here, it will appear again. How does it happen? This is how it happens. Please do well to subscribe if you haven't. Okay, now we are to convert this number, these binary numbers, okay, to denary, to base 10. So this is the method we are going to apply. We are not going to include the zeros because these 2 will vanish right at the 0 points. So pick this first one, write 1, then times 2. Don't bother about the powers, the exponents. Just forget about the exponent first. All right, then go ahead, pick this second one here, then multiply it by the base again. So this is base. Don't bother about the exponent first. Just forget about the exponent now. All right, then the next one, which is the very last one, is this one here, which is 1 times 2. Don't bother about the exponent. Now that we have done this, the next phase is now for us to put in the exponent. So what are the exponents? Let's look at it strategically. We know that here, these 2 will carry what? 0, right? Yes, what it means is that we are going to have 0 here. This is 2 raised to power 0. Okay, let me write properly. It's 2 raised to power 0. Then here, what will be on this 2 here? we're multiplying this second one. This is 0, this is 1, okay, this is 2, which means here we are going to have 3, right? So which means we are going to have 3 here. That is what will be here, okay? Here will be 3. Then what will be right here for 2? We're multiplying this first one. This is 3, so here will be 4, and here will be what? 5, which means 2 will be raised to the exponent of 5. That is what it is, okay? So right now that we have our exponent, we have seen that 2 has disappeared here, here, and here. This is the vanishing trick. Once you use this, you are simply going to use 2 raised to the power 5, which is 32. Okay, that is 1 times 32. This is 32. Then plus, this is 1 times 2 raised to the power 3. Okay, 2 raised to the power 3 is 8. 8 times 1 gives us 8. Then plus, then here, 2 raised to the power 1 is 1. Okay, 2 raised to the power 1 is 1. Is that taken? So, but if I want to take it gradually, let me take it gradually so that we don't waste. I know we don't want to waste time, but we have to be very careful. This becomes 1 times 32, which we are already used to. Then this becomes, this second one here becomes 1 times 2 raised to the power 3 is 8. Then plus, this is 1. Okay, we have to understand that in the law of indices, whatever is raised to the exponent of 0 becomes 1. No matter what, whether it's a letter, a number, an alphabet, or a symbol, as long as it is raised to the power of 0, it will always give us 1. So we can go ahead and multiply. 1 times 32 is 32 plus 1 times 8 is 8. Then plus 1 times 1 is 1. So our final answer here is 32 plus 8, which is 40, then plus 1. This gives us 41. And to the base of 10, okay, because we have to convert to the base of 10. This is how simple this method is. It is known as the vanishing method. In the examination, this is not going to give you any headache at all. All right, so do well to study the vanishing method. It's also used in metrics. I will briefly bring in matrices here to experiment the vanishing method. All right, so please take note and do well to study this method. You can always use it in any of the question that has 0 if it allows you to use. Okay, that is the vanishing method. So I do hope you understood this. I do hope you understand this. You understood this. But if not, leave a chat. Let me know your thoughts about the vanishing method. I want to see it in the live chat. Please let me see if you are going to, if you approve of it and if you like this method. It helps a lot because you don't have to waste your time with the zeros. So thank you very much. Let's quickly move to the next phase. I do hope I'm not talking to myself alone. I hope I'm talking to the candidates for the examination, because this examination is for you. So it's going to be to your benefit when you apply this. So let's quickly take the second one, which doesn't waste time. We are still going to look at this second one, convert. So I don't want to waste your time. We are still going to use this one here also, but let's look at question number 2 using vanishing method. Okay, the 10 tricks alone. So let's look at this. This is an equation. Okay, I'm bringing this for our own understanding. Okay, the question is this: find x if look at if x to the base of 2 all squared is equals to 1 0 0 1 0 0 to the base of 2. This is the base of 4, and this to the base of 2. Okay, This is base 2. Yes, you will wonder how you are going to solve this, right? But I can boldly tell you that this is the cheapest, the simplest questions. Okay, it is one of the simplest questions we've ever seen. Yes, but some students will be trembling. How do I solve this? This is in base 4. This is in base 2. Okay, now to solve a problem like this, we have to convert both sides. Okay, convert both sides to base 10. Right? We convert to base 10. So how do we convert to base 10? It is very easy, so easy. So this is 2. Don't forget this is square. So don't bother about the square, okay? Just convert what is inside to base 10. Remember it's base 4. So we are going to convert to base 10. It means if we convert this to base 10, we are going to have 4. This is the base, then times x, okay? Or x times 4. 4 times x. This is the base. Because it is 4 is the base, right? So which means this 4 will be carrying 0. Okay, this 4 will be carrying 0. Let me re-express it. Maybe this will be better understood. Now here we are going to write x times 4. Okay, it will be raised to the power of 0, which makes it 1. And it is now squared because of the square here. Then use the vanishing trick here. So what is the vanishing trick? This base 2 will hibernate at these 0 points. Okay, it will hibernate, which means we have only 2 numbers we are going to use. Okay, this one and this one. So we are going to write 1 times 2 here, which is the base times this one. Then plus this second one times 2. This is what we are going to do. So what do we do again? Focus on the exponent. What is the exponent? Here, the exponent here is 0. Here we have 1. Here we have 2. Here we have 3. Here we have 4. Then here is 5. That's the exponent. Okay. So these are the exponents for each positions when 2 is coming to take or multiply any of the digits. So which means here, this is the 1 here. So 1 times 2. Okay, 1 times this 2. So the exponent will be 2 here. That is what it's going to be. Why here, which is the very first one. So the exponent will be 5. The exponent will be 5. So what will this be? This is x times 1. Okay, raised by 2. Of course, this is 4 raised by 0 is 1. Then times raised by 2. Okay, then what is this? This is 1 times 2 raised by 5 is 32. Then plus, then this is 1 again. This is 1. 2 raised by 2 is 4. That is what we are going to arrive at these positions, right? So the next space we are already aware, x times 1 is x, which means we have x squared here. We end up having x squared here. Then 1 times 32, obviously, is 32. And here we have 1 times 4. 1 times 4 is 4. So what's the implication? X squared is equals to 32 plus 4 is 36, with no doubt. 36. So if the square of x is 36, then what is x? Put it in the comment section below. Okay, before I give the answer, what should be in the comment section? So what is the answer? Yes, because the square of x is 36. Both of them are perfect squares, right? Yes. So the answer will be x equals to 6. That is the solution to this question. I do hope it is well understood. You can see that we have used the vanishing method to simplify our work and save our time. So this is why it is important we understand this trick. I'm going to verify this trick using the matrices, okay, method to handle this vanishing method. And you are going to see that with matrices, it also works. Okay, so thank you very much. I do hope you are with me. Please do well to smash the subscribe button if this class is interesting to you. And if this class is of good value to you, do well to smash the subscribe button. I'll be I'll be more than happy to be with you and also be your teacher this morning. I appreciate your presence here because without you, there will be no AZ Science TV. So we are very much grateful having you here. So I'm going to re-explain this, all right? But before I do that, let me know in the comment section how you want me to do this better for you and which other topic will you want me to treat, all right? Because that is why we are here. JAMB is very close. That is why we are doing this often and often. I think I did it severally last week. I did a little actually, but this week is going to be more of fire brand classes. So this is a splash of the class. So please do well to be part of us. We appreciate your presence here. Okay, and we do hope that you will continue to. So you said, please teach algebra. Oh, okay, that is Valley S9C. S9C, yeah, Valley S9C. You said I should teach algebra. Yes, I'm going to teach algebra. But don't forget that this is also algebra. This is also algebra because we can see X there, right? So when you have X, it's also algebra. So when you tell me to teach algebra, please, I want to know the exact place. Is it quadratic equation? Right? Is it simultaneous equation? Is it which of them? Is it algebraic fractions, linear algebra, or is it inequalities? These are all algebra. Okay. There must be some key areas you want me to teach, but I'm going to go through all the algebraic topics before the end of this week. Don't forget that because JAMB is very close and staring at us. So now let's look at the vanishing. We are done with the vanishing method, right? We have used this method for vanishing method. Now let's look at vanishing method in matrices. Okay, we look at vanishing method in matrices. So I'm going to look at that now so that we are going to walk our way through so that we will have a better understanding of what we are dealing with. So let me just let this go. Yes, trick, vanishing method, matrices. Let me use matrices to explain vanishing method because I did it last time, but I don't think a lot of persons attended that class. That was on Saturday. So I'm going to use this method now. Now, evaluate. Okay, that's question 3. Please, this is question number 3. Okay, we have to evaluate this. Evaluate 1, 0, 1, 2, 4, 3. 3, 2, 5. Okay, this is one of the questions. This is one of the questions we are going to deal with. This is matrices, and we are using the vanishing trick. Now, the vanishing trick is a simple trick where you follow the path of 0. You see this path? This 0 is very important. Why? Because there's 0 here, we are not going to work with the matrices of the cofactors of 0. So we'll forget about this 0 and focus on only this one and this one. Okay? Yes, we'll focus on this one and this 2. Sorry. This 2. Yeah, this one and this 2. Okay? We are not going to work with this 0. So let's focus. Remember that yes, I'm going to treat algebra, okay? Yes, is the next topic. The next topic I'm going to treat after this now is algebra. Remember, it is 5 tricks. This is just trick 1. Okay, trick 1. You can also use it in algebra. But let's proceed. This is 1, 0, 2. Okay, so don't forget that here we are going to have plus, here minus. Okay, this second place will be minus, while here will be plus. I'm sure we know where this is coming from, right? Yes, this is matrices. When finding the determinant of a matrix like this, we start with a plus. Always start with a plus. Okay, this is plus, except if there is 0 here. This is determinant, whatever. So let's use this symbol. Okay, let's use this symbol delta as determinant. So that is plus this one here, then open bracket. Now what we are going to do, cross the column of the one, of this one, then cross the row. Whatever we did not cross is the matrices of the cofactors of 1. So the implication here is that this one is going to be cross multiplied. This is, remember, we have already crossed this one because it is the row in which one belongs, or to which one belongs. Okay, one belongs to this row, to this column, and one belongs to this row. Therefore, we have crossed the row and crossed the column for one. So we are left with this because we did not cross this one. So the question is, we are going to have 4 times 5. Okay, 4 times 5. We are going to have here 4 times 5. When you write 4 times 5, just quickly write minus. This minus is a determinant minus. Okay, it's a determinant minus. It must be there. Then 2 times 3. Okay, you are now going to have 2 times 3. Don't forget this. Then the next one here that I want you to take note of is this 0. Remember there is 0. We are not going to include this. We'll go straight to 2, which is another one again. So we'll go straight to 2 and write plus 2. Then open brackets. Check the row. This is the row for 2 and this is the column. So strike the row and strike the column, which means we are now left with this. Okay, we are going to work with this. We didn't cross this one, which means 2 times 2. That is 2 times 2. Then minus 3 times 4, which is 3 times 4. This is all. You can see that there is a vanishing trick here, right? Because we didn't work with 0 here. If you work with 0 here, everything that concerns 0 will disappear, will hibernate. That is the vanishing trick. I just want to use this one to exemplify it for better understanding. All right? So we proceed. Let's quickly solve it so that we don't waste our time. This is plus 1. So there's no need for 1. You can let 1 go, right? Because 1 has no... 1 is called identity element or of multiplication, or what you call multiplicative inverse or so. I think it's something like that. What you call identity element. 4 times 5 is 20. That is 20 minus 2 times 3 is 6. Then here we have plus 2. 2 has a value, okay? 2 times 2 is 4. Then minus 3 times 4 is 12. So that is what we have right here. Then the next phase is to take the difference. 20 minus 6 is 14. Then we have plus 2 here, open bracket. 4 minus 12. Remember, this number is bigger. You are subtracting a bigger number from a smaller number. So we are going to have a negative sign here, and that is minus 8. That is minus 8. This gives us 14. Then plus times this minus is minus. And 2 times 8 is 16. 2 times 8 is 16. Then we can take the difference here. What's the difference between this? Remember, it is a bigger number being subtracted from a smaller number. Therefore, we are going to have minus 2. This is the answer to the question. This is what we call the determinant, okay, of this matrix. That is how simple it is. All right. So it is the vanishing method because the 0 has made something to disappear, right? Yes. If you use 0 here, it's okay. Just imagine that we use 0 here in place of 2 or in place of 1. Let's assume that in place of 1, we use 0 here. When you use 0 to multiply the whole of this bracket, it will disappear. It will vanish. The whole of this bracket will vanish. So that's known as the vanishing trick. Please don't forget this. This is very important. So I hope it is well understood. If you are just joining and you have not subscribed, please do it to smash the subscribe button. I want you to be a part of this life-changing class. Okay, especially for those who are writing JAMB or who are going to sit for JAMB. And if you know anyone who is going to sit for JAMB and the person is not watching, yes, probably the person is not aware, please do well to share this live video so that the person can have an opportunity to benefit from this. It's a free class. I'm not telling you to pay anything. So nobody's paying anything for this class because I want everyone to succeed and to do well. All right. So we are not charging anybody anything. So you talk about algebra. Welcome to algebra. Yes. I know you're wondering, oh, when am I going to do algebra? Because somebody is just asking, hey, algebra, where are you? Yes, algebra. That is where we are now. And the first part is called the simultaneous equation. Yes, simultaneous equation. That is the algebra we are going to deal with now. The simultaneous equation. That is, I'm going to use trick number 2. Okay, yes, it is called the simultaneous trick. Simultaneous trick. So a trick for simultaneous equation. And that trick was derived from matrices, actually. Okay, it's a kind of matrix derivative. So simultaneous equations. Yes, in algebra, like equations and expressions, we have so many tricks that you can apply. So let me look at trick number 1. Trick number 1, or trick number 2, sorry. Trick number 2. Okay, what is the name of the trick? It's called the matrix trick. The matrix trick. Yes. How does it happen? If you check, you see that it's matrix. I'm going to show you. Okay, you will notice that it is actually matrix, but it has been simplified in such a way that you don't even have any issue. You don't need to bother yourself, all right, about anything. So simultaneous trick. Now let's say we have to solve this question. Question number. Okay, this is question number 4. Okay, this is question 4. We are going to solve this question. Solve the simultaneous equation. We have to solve the simultaneous equations. Simultaneous equations. So simultaneous equations are usually in pairs or even more than 2 bits. We are not going through that level now. What are the equations? We have 2x minus 3y. 2x minus 3y equals 10. And we have 10x minus 6y equals 5. So this is what we have to solve now. Okay, I'm going to show you the simple trick to solve this. Don't use elimination method, substitution method, graphical method, or which other method? You know them. We don't use the methods here. The reason is simple, because it is JAMB. Before you eliminate, you have eliminated the time too. So just see how you can solve this problem without eliminating the time or wasting time using all this conventional method or traditional method. So I'm going to teach us how to use the how to use the unusual method that is not taught in school. This method is not taught in school. Okay, most schools don't teach them, and that's why universities take advantage of them. That's why JAMB take advantage of them. They know that we are not taught, so they want to take advantage of them to deal with us. But we are saying no to that. Okay, now this is 1. This is 2. Okay, this is 1 and this is 2. So what do? We are going to find x and y, right? Good. Write x here and write equals to. Write a division line here. Okay, do the same to y. Do the same to y and write division line here. Just follow me carefully. When you learn it, then you can go ahead and speedily do it so that you can save your time in JAMB. But because we are learning, that's why I'm following it gradually. Now we are going to look for the denominator first. Okay, both of them have the same denominators. You can see that it's matrices, right? Yes. How do we get the denominator? Look at it. Cross multiply these two. Yes, because these ones are the elements of the matrix. Okay, that makes this simultaneous equation. These are the elements of the matrix. So let's go ahead. Well, let's cross multiply, right? Always start from here. 2 times minus 6. That's what we have here. 2 times minus 6. So 2 times 6 is 12. And there's minus here. That is minus 12. So we're going to write minus 12 here. Write the minus 12 here again. Repeat it here. The way you did it here, do it here, because they have a common base. Then, when you are done, write another minus, because that is determinant. Okay? This is determinant minus. Then do the same here. Minus 3 times 10. Okay? Minus 3 times 10. What does it mean? It means there's another minus, right? Minus 3 times 10 is 30. So write 30 here. Okay? Write it here carefully. Then do the same here. Minus 30. Now we are done with the denominator. Yes, we can go ahead. We will later find it. You just write equals to here. But let's look at the numerator. The numerators are not the same. They are different. Okay? Now, when finding x, cross multiply the coefficient of y. Use the coefficient of y for x. And use the coefficient of x for y. That is very important, please. Use the coefficient of y for x and use the coefficient of x for y. So now we have to find x. We are going to cross multiply the coefficient of y, not x, the coefficient of y with these constants. And we are going to start from here. If it's x, if it's y, we'll start from here. Okay, now cross multiply this way. Do it again. What you did here, repeat it here. But start with 10 and minus 6. So 10 times minus 6. Okay, 10 times 6 is 60, right? But it's minus. That's why it's minus 60. So write minus 60 here. Then when you are done, quickly write minus here, because you are going to do the same thing here later, but not with minus 60, because they are not the same. Okay, then go ahead. Do this to 5 times 3. Don't forget there's minus here too. So 5 times 3 is 15. And because there is minus here, we write minus 15. Don't forget, not this minus, but another minus again. Minus 15. Minus 15. Then we'll close the bracket. So we can go ahead and simplify this, right? So that gives minus 60. Minus 60. Minus times minus is plus, right? Minus times minus is plus. Then this is 15. Okay, that's plus 15. Plus 15. And we know how we got this. 5 times 3 gave us plus 15. So, and that gives us this too. We can do the same here. Minus 12. This is minus 12. Then minus times minus is plus. Okay, that is plus 30. Plus 30. Right? So we can go ahead and simplify, right? So if you simplify, what are we going to get from here? Minus 60. Sorry that I'm going this way, okay, because of space. So minus 60 plus 15 is like subtracting a bigger number from a smaller number. So we have minus 45. Minus 45, right? So this is 12, yeah, because it's 6 times 2. So minus 12 plus 30 is like subtracting a smaller number from a bigger number, right? So take 10 away from 30, we are left with 20. Then take 2 away from 20, we have 18, right? We are left with 18. And it's plus, okay? Because the bigger number has plus, so we have plus here. Then we can go ahead and use 9, reduce the number, okay? Divide by 9 up and down here. So 9 into 45, don't forget it's minus here. 9 into 45 is 5, right? Because 5 times 9 is 45. Divided by 9 into 18 is 2. So this is our value for x. I gradually showed you so that you will understand it. But in an exam condition, don't worry, I will explain it. Okay, in an exam condition, it speeds off your work. You don't need to write some things. Okay, you don't need to write it. So the answer here is minus 5 over 2 for x. You see that it's very straightforward, easy, no substitution, no elimination, no graphical method. Okay, then for the second one, remember it's y. So we are going to use the coefficient of x because it is y, and we'll cross multiply it with y, with the constant. And when doing that, you are going to start from here. Remember, we started from 10. 10 times this, right? But no, this time we are starting with 5 times what we have here. So 5 times 2 is 10. So we are going to write 10 here. Begin by writing 10 here because it's 5 times 2 here. Okay, we are cross multiplying from here down here. That's 10. Then 10, remember your minus, please. Don't forget this minus. Then 10 times 10. Okay, 10 times 10 is 100. This is 100. This appears very easy. Yes, 5 times 2, which is 10, then minus 10 times 10. That is 100. And we know what it is, right? Remember, both of them have the same denominator. So if here is 18, it means that here will also be 18. So there's no need wasting our time. Okay, this gives us minus 90. Don't forget that we are subtracting a bigger number from a smaller number. So we have minus 90 divided by, so what happens next? The whole of this will give us 18. Don't waste time, okay? Remember they have the same denominator, and this gave us 18. So this will also be 18. 9 can also divide, right? Yes. 9 into 90 is what? 9 into 90 is 10. Okay, I hope I'm right. Yes. Just divide by 9. Then divided by 9 into 18. 9 into 18 is 2. Right? 9 into 18 is 2. But we can see that it can still go, right? You can see. So, which means 10 divided by 2 is 5. This is the value for y. This is the value for y. Okay? Yes, this is the value for y, and this is the value for x. These are the two answers to the question. You can see how simple you can get this done. There is no need to waste time. So if this class actually makes sense, if it shortens your trick, the metrics trick, if it shortens your journey in mathematics, please don't forget to like and share. And if you are just joining me, do well to subscribe. I hope I'm not talking to myself alone. I do hope that others are with me. Okay, so please do well to share so that others can join. I will be happy to see a lot of persons joining this class, because this class is an expository class. It's an expo class, okay, to make sure that JAMB is no longer a difficult thing for majority of us, because that has been the challenges. Even when I wrote JAMB, it was a challenge, so we had to overcome using some of this trick. Okay, so thank you very much for joining. I do appreciate you, because your presence here makes the difference. So I appreciate you a lot. Thank you very much. Now we are going to continue in our class. Now I'm going to bring another question for better understanding. Okay, just understand what we did here. Let me re-explain, then I proceed. Here we have x, okay, x and y. Remember, we have to find the values of x and y. That is the aim of the whole of this thing. When finding the value of x, use the coefficient of y to multiply the constant. Cross the coefficient of y when finding x. And when doing it, start with the first constant here, with this. Okay, that gives us minus 60, which is what we got here. Then cross it with this, that's minus 15. Look at this. Okay, but don't forget that both of them, both x and y, we have the same denominator. Don't forget that, okay? Then when finding y, use the coefficient of x with the constant. And when doing it, start with this. If you start with this, cross multiply here, this is 5 times 2, right? That is 10. Then minus 10 times 10, which is what? 100. So that is how to do this. Please do well to study it and subscribe. Keep being a partner with AZ Science TV. We appreciate you a lot, okay? Your presence here cannot be underestimated at all, and cannot be overestimated, because it's just that your presence here is what makes AZ Science TV live and still running very far, despite the numerous challenges we have gone through for the years. So I appreciate you a lot. Thank you very much. Now let's solve this. Let's solve this. I'm going to show you another way to solve this question. Let's look at this question. This is the first trick. Okay. Yes, I'm going to teach you the second trick again. The second trick is what we call the plug-in trick. The plug-in trick. The plug-in trick. Yes, it's another trick, but that's not what we want to do now. Let's use this method to solve this problem. Okay. This is The solution to the simultaneous equation is what? Okay, the solution, this is another way to ask the question. The solution So this is how to still ask this question, okay? Yes, this is how JAMB can still ask that question when you find simultaneous equation like this. For that person or that viewer who said I should treat algebra, please, this is algebra, right? Yes, I appreciate you a lot. So I know that your presence will definitely continue to impact AZ Science TV. Thank you very much. Yes, you said I should teach algebra, so this is algebra. Okay, don't forget, this is algebra. Where are you located, sir? Okay, I appreciate you. Please, I'm here in Nigeria, okay? Are you in Lagos State? No, I'm in Edo State. Do you do home teaching, sir? Yes, I do home teaching, but I can also teach online, okay? Yes, if you want me to partner with you, if you, okay, do you do home lesson? Yes, of course I do home lesson, but my home lesson can be online, okay? I don't go home to teach, but I do teach online. Okay, if you want to reach me, use my use the official Gmail of this channel, azsciencetv@gmail.com. Okay, azsciencetv@gmail.com. When I post this online, I'm going to bring in the email. I think I skipped that while putting the description, so I'm going to do that. Okay, don't worry about that. I teach. Okay, so let's look at this. Let's follow this part. Okay, the solution to the simultaneous equations is what? Yes, what are the solutions? What is the solution set? Okay, now this is what we are going to do. Same method, just write solution. Of course, what are we looking for? Solution. That's what we are looking for. Okay, yes, we are looking for solution. Now, how do we get the solution? X, right? X and write Y. Okay, write X and write Y. So let our X be here and let our Y, yes, let Y be somewhere around here. Sorry, I'm going to put it here. Yes, let our Y be somewhere around here. Yes, there's something we want to do. What is that we want to do? Okay. We want to find the values of X. So can you help us? Does anyone have an idea on how to solve this problem? Yes, I'm very happy to see you solve this. Yes, I know we are not familiar with the method. Elimination, substitution, graphical method. JAMB does not want to hear that. Let's proceed. So, write the line of denominator, division line that separates the denominator from the numerator. Do same here. Okay, when finding X, use the coefficient of Y. Then when finding Y, use the coefficient of X. All right, but before then, let's find the common denominators, what you call LCD or LCM of the denominator. So how do we find it? Just use this one here. Cross multiply. Starts from this, not from this. Please don't start from here. Start from here. 3 times 3 is 9. So we are going to write 9 here, minus. Then we'll write 9 here, and also write minus. Remember, we have done this. Then we'll go this way. 4 times 5 is 20, right? So that is 20. Do the same thing here. Is 20. All right? So what's the next thing to do? It's time to find X. When finding X, use the coefficient of Y. These are the coefficient of Y, right? 5 and 3. That's +5 and +3. The signs are very important. So cross multiply it with this. This is what we are going to do here. Start with 4 and 3. Okay, we are going to begin with 4 and 3. So 4 times 3 is 12. Remember, we are writing it here because we are using the coefficient of y. Therefore, it's for x. If we are using the coefficient of x, it is for y. So 4 times 3 is 12. Then 5 times 5 is 25. Don't forget this sign. This minus is matrix minus. So 5 times 5 is 25. We are done with this. So let's proceed. What is 12 minus 25? That is 25 minus 12. That is the negative of 25 minus 12. So what is 25 minus 12? It's 13, right? Yes, which means we are going to have minus 13 divided by 9 minus 20 is minus 11. Am I right? Yes. The minus cancels the minus. We are therefore left with 13 over 11. Sometimes JAMB will leave their answers in improper fractions like this. Okay, now we are done with x. This is the value of x. X is 13 over 11. That is x. Now let's go to y. When handling y, use the coefficient of x. Cross multiply the coefficient of x with the constant. Don't start from here. Just, we started from here, right? When finding that of x. This is y. So to get the value of y, start from the base here and cross multiply it with this. So 5 times 3 is 15, right? Write it here. Then minus. This minus is matrix minus, determinant minus. That's what we have here. So we have done 5 times 3. Now let's go ahead and do 4 times 4. 16, right? Minus 16. That is how simple it is. Okay, so what is our y? 15 minus 16. Don't forget that 16 is bigger than 15. So we are subtracting a bigger number from a smaller number. So 15 minus 16 is minus 1 divided by 9 minus 20. Remember, they have the same base. So just write minus 11, just like we did here, because they have the same base. So there's no need to be bothering ourselves. All right, they have the same base. 9 minus 20, 9 minus 20. So minus cancels what? Minus. We are now left with 1 over 11. This is the value of y, and this is the value of x. It is so easy. You don't need to follow the traditional method, especially in UTME. They kill time. Plenty question, tiny amount of time. So you cannot afford to be using elimination method, substitution method, graphical method. Where are we going with that method? We cannot use it. Use this matrix method, in which you just cross multiply and subtract and divide, and that's all. So these are the simple way to handle this type of question. So if you are enjoying this class, if you are benefiting this class, if this class is fun to you, and if you are discovering something new, okay, from my class today, please don't forget to share this video, like the video, okay, thumbs up for this video, please. I need your thumbs up so that YouTube can keep sharing this video or showing the video to wider audience. You are the one to determine whether this video will go wider or not. So I appreciate you a lot for this, for joining this class. Remember, this is trick 2. Trick 2 is the trick I called the matrix trick. All right, there is a third trick known as the plug-in trick. It's used for any algebra, not only simultaneous equation. As long as there is a solution to that equation, you can use the plug-in. Bring in that solution. Okay, that is called the trial and error method. It is a plug-in solution. It can also help. The time you are using to solve this, you can just plug in and you get the answer straight. It still doesn't waste time. I'm going to teach that trick. That will be the next trick. That will be trick 3. Remember, it is 5 tricks. So we are going to look at trick 3. All right, so that is that for this. Any question? Please, if you have any question, put it in the comment section. If you have any suggestion, put it in comment section. We are ready to take your suggestions and we are ready to answer any question. I appreciate you for your comments. Thank you very much. Your appreciation can I'll keep appreciating every one of you. All right, so thank you very much. Let's move on to the third trick. That is trick number 3. Trick number 3. That is the next trick we are going to handle this morning. So we are done with this. We are still in simultaneous equation, don't forget. Then we are going to use trick. It is what called tricky method of answering the simultaneous equation. We are not using the matrix trick again. We are using what we call the plug-in trick. Plug-in trick. Yes, I'm going to use the plug-in trick for so many equations. So let me call it here. Let me call it plug-in trick. We call it the plug-in trick. The plug-in trick. Yes, that's what we call it. It is known as the plug-in trick. It is the trick number 3. Trick number 3. Plug-in trick. It is very good for any algebra that has solution, and the solutions are already listed in the objectives. Okay, A is this and that, B is this and that. So the values are already listed. Since they are already listed, go ahead, test them, use try and error, test the tricks. Test using this trick, the plug-in trick. Okay, test each of the values. This is what we are going to use for solving these problems. So let's look at this so that we can better understand what we are talking about here. Okay, if I have something else equation, okay, yes, I have one here. Solve the following equations. I'm going to use this now. Okay, solve the following equations. That's question number 5. Or no, this will be question number 6. I think so. Okay, let's call it question number 5 or anything. Later we'll know. So this is question number 5. Solve the following equations. Solve the following equations. They are usually systems of equations. So what are the equations? Equation 1 is, okay, equation 1 is 4x. This is very wonderful. So let me just show you the equation so that you see how nice it is. 4x minus 3 is equals to 3x plus y is equals to 2y plus 5x minus 12. Now, you can see how interesting this might be, right? You can see how interesting this equation is. This is a simultaneous equation. What are you thinking in your heart now? Drop it in the live chat. What are you thinking? How do you think we are going to solve this problem? I know you are thinking what I'm thinking now. But what you are thinking right now is not what we are going to use here. We are going to use the plug-in. So we are not separating this thing. We will leave it like this and be plugging in. You see? I don't know if you understand what I'm saying. Yes, we are going to plug in this. We'll plug in the solution. So what are the solutions? The solutions are given in the question. So you already know the question, right? So let's plug in. Let's look at the solutions for better understanding. So we are giving these solutions. We are giving x, y. We are giving x to be 5 and y to be 2. That's for the first one. Then the second one, we are giving x. We are giving x to be 2 and y to be 5. That's 2 and 5. Okay, the first one is x, the second one is y. The first one here is x, the second one is y. Please don't forget that. Then for C, we are giving both of them to be minus 2 and minus 5. That's x and y, right? Then for D, we are giving both of them, okay, one is minus and one is plus. X is 5 here, while the other one is minus 2. Then the last one here, which is D, the D part, we are giving x and y. But here we have minus and minus here. Can you see this now? Yes, I know you want to ask. So what do we do to solve this problem? It is called the plug-in trick. You can solve any problem with it. And this one, this is something else, right? We can use something. We can separate this equation 1, equate this to this, you know, and arrange it. Equate this to this and do what? And arrange it, right? Yes, but I can solve it using the plug-in method. Yes, we are going to start with the positive values. We'll start with this. This is A, B, C, D, and E. So let's profile the solution. Solution. What is the solution? Can you give me the solution based on what I have here? I know we've not done plug-in method, right? But you can use the other method to rearrange it, but that's not what we want to use. So let's see who can give us the solution before we start. Yes, what do I do first, or what do we do next? Let me know in the chat box. Let me know in the chat box. What do we do next? Yes, I'm waiting to hear from you and to see your chat in the chat box. Yes, I'm waiting, and I'm more than happy to see your chat. So what are we saying? What do we do next? Oh, thank you for your likes. I appreciate you for the likes. I do hope we have subscribed too. Okay, I do hope we have subscribed. I appreciate you. You are just very wonderful people. Thank you very much. All right, I appreciate you. So we are going to continue from here. Okay, let's continue now. Plug-in method. Yes, this is 5 and 2, right? Remember, this is X and this is Y. Don't forget, the first one here is X. The second one is Y. So this is X and this is Y. X, Y, X, Y, X, Y, X, Y. So we'll start from here. Let's go. Take 5. Okay? Take this one here. This is X. X is 5. 4 times 5 is what? Let's proceed. Let's plug in this. Okay, that is what we call attempt 1. So I'm going to clean this because of space. Maybe in my next class, I'll make it horizontal orientation. So the first one is this. Let's plug it here. 5 times 4, okay? This is 4. Where is X? X is 5. Then minus 3, right? Minus 3. Then equals to 3 brackets. What is X? X is 2. Don't forget that. We are plugging in. We are plugging in. That's 2 plus, what is Y? Y is 5. We are plugging in. We are plugging in. Equals to 2. We have 2 open bracket Y. What is Y? Y is 2. We bring it 2 here. Plus 5 times X. So what's X? X is 5. X is 5. Then minus 12. I hope you can see all the numbers because the numbers seem to be very long, right? Yes, I hope you can see all the numbers. So thank you very much. I can see all the numbers, and I do hope you can see it. Sorry, just bear with me. I know it's quite long, right? It's quite long. So let's do it. 4 times 5. 4 times 5 is 20, right? 20 minus 3 equals to 3 times 2 is 6, right? Then plus 5 plus this 5. Then equals to 2 times 2 is 4 plus what is here? 5 times 5 is 25. Then minus 12. Yes, we are plugging in. We want to know if this is the answer. If this is the answer, this will be equal. They will all be equal. Okay? So let's proceed. 20 minus 3 is 17, right? But here, is it 17? Okay, sorry, I think we made a mistake here, right? Did we? Okay, this is 3 times 2, which is 6. Then plus 5. Plus 5. Yes, 3 times x. 3 times x. I think we made something wrong here. 3, this is 3 times x, please. 3 times x. Can you see it now? This is 3 times x. Our x is 5. In the second part, 3 times x. So our x here is 5. Sorry, I made a mistake here. This is 5. And this is 2. Okay? Yes, our y is 2 here, and our x is 5. Sorry for that mistake, okay? I apologize. So let's proceed from here. 3 times 5 is 15. then plus 2. Is that taken? Then, okay, let's go ahead. So 20 minus 3 is 17, right? 15 plus 2 is 17. Then 4 plus 25. 4 plus 25 is 29. So 29 minus 12 is what? What is 29 minus 12? Let's look at it. 9 minus 2 is not 7. Yeah, it's 7. Then 2 minus 1 is 1. You see that is 17, right? Yes. Have we not gotten it? So this is the plug-in method. Okay? If you see that this is 17, 17, 17. If at the end of the day you didn't get 17, 17, 17, then go ahead, use another pair of numbers. Okay? Use another pair of numbers, X and Y. Keep plugging in. That is called the plug-in trick. So the answer is actually this. This is the solution to this equation. So if you solve this simultaneously, you will get 5 and 2. Your X will be 5 and your Y will be 2. That is what we are going to get, okay, as a solution to this question. I do hope it is well understood. This is the reason why we have to use this trick. It is also very good. If you don't want to use the matrix method or the matrix trick, use the plug-in trick and get yourself flowing, okay, and moving with time, because time is the issue. Now, the plug-in method, I have used it for simultaneous equation. You can use it for any simultaneous equation when the solutions are given. Like here, the solutions are given, all right, so we have to use it. Now, let's use plug-in method for the next topic, which is quadratic equations. We are going to use the plug-in method for quadratic equations. So I do hope this method is well understood. Yes. If you didn't get it, use another pair. You can use the minus 2 and minus 5, okay? Or you interchange these 2 and 5. So, and we're going to get the same answer. We proceed straight to quadratic equations because we have been dealing with simultaneous equation. So let's look at quadratic. What is a quadratic equation? A quadratic equation is an equation in which the highest power of the unknown is 2. Okay, the highest power of the unknown is 2. That is a quadratic equation. So we are going to use the plug-in method. It is very easy. Okay, now in quadratic equations, there are other tricks. Yes, there are other tricks in quadratic equation, but the plug-in method is the popular tricks for any algebra. Okay, yes, the viewer that said, oh, treat algebra, this is already algebra. Quadratic equations is they are part of algebra. Okay, so they are part of algebra. Now let's look at this one, the larger value for y, which okay, the plug-in method. Just look at this. I want to show you something here. Question number 6. Let's call this 6, please. Okay, the larger value of y. For which y minus 1 square. Okay, let me make it bigger. Okay, I hope you are going to see it better when I make it bigger. For which y minus 1 square equals to 4y minus 7 is dash. Okay, is what? So this is how JAMB asks questions. Okay, this is how JAMB will ask the question. A question like this. You see that this is quadratic, right? In nature, if you expand this one, okay, you are going to have quadratic equations. But we are giving answers. What are the answers? Look at the answers. We are giving A to be 2. Then we are giving B. We are giving B to be 4. Then we are giving C to be 6. And we are giving D. We are giving D to be 7. And E is 8. Yes, E is 8. All right? E is 8. This is exactly what we are giving. I do hope you are following what I'm doing here. We want to use the plug-in method. Don't expand and start factorizing or using any of the quadratic method. What are the quadratic method? Completing the square method. Formula method, what you call the general formula method or quadratic formula method or factorization method. Don't use these methods. They can waste time, so don't use them for quadratic equations. This is what you are going to use. Pick each of this one, plug them in here, plug it in here. If you pick 7, if you pick 2, put 2 here and put 2 here. If you pick 4, put 4 here, put 4 here. If you pick 6, just keep doing it. There's no way you will do it up to this level and you not get answer. You must get an answer, and that solves it. Okay? Remember, there are 2 answers, but we need only 1. That's why they gave us 1. So let's begin. This is called attempt 1. Yes, the first one attempt gave us answer. So we'll start from the smallest. All right? So let's start from this solution. Let me call it solution. So we'll be doing it one after the other. Anyone who don't get the answer, we'll clean it. So this is y. So pick 2, right? 2. Put 2 here. We have 2 minus 1. It's not squared. Yes. Equals to, this is 4 bracket y. Our y is 2. So we'll bring in 2 here. Minus 7. So let's check if both sides will be equal. If both sides are equal, it means that the answer is A. Then we go. That is the end. If they are not equal, then we'll test 4 until we get the one we are going to plug in here to make both sides equal. That gives us the answer. So if you know the answers, can you just tell us? Please, do you think this is the answer? If both sides are equal? Yes. I want to know in the chat box. Is this the answer? Please let me know in the chat box. I'll be more than ready to look at it. I'm going to look at the chat. Okay? Just look at the chat. Please put it in the chat. I want to know. If they are equal, let me know quickly in the next couple of seconds. Yes. So who is going to be here for me? Who is going to, yes, I have subtracted. Okay. Do you do homework? Yeah, I did. So is that the answer? I want to know, please. I want to know. Let me know. Yes, I have subscribed. Oh, you have subscribed. Thank you very much. Ebi Keme, Terry, Job. Yes, you said you have subscribed. That's very good. I love that. Please, if you are not subscribed, do where to subscribe. Okay. Yes. What is the answer? What is the answer? I want to know. Yes. Okay. We have. So I'm not seeing any response from you. Please, now you're watching. Just let us know. Okay. I want you to give me answer to this. Okay. You don't want to answer me, no problem. We can still do it together, right? So I appreciate you for being here. All right. So it's not the answer. So, okay. Yes, I have. Yes, somebody say it's not the answer. No, it's not the answer. How do we know? Let's try, okay? How do you know that this is not the answer? I want you to be, let's go. Let's see. This is 2 minus 1 now, right? Yes, 2 minus 1 is 1. Then we square 1, right? What is the square of 1? It's not 1. Come on. Then let's look at the second one here. This is 4 times 2. So 4 times 2 is 8. This is 8 minus 7. Come on, tell us now. So are you still convinced? Or do we have any doubts that that is not the answer? So this is actually the answer. From what we have here, okay, this is the answer. Because 1 square is 1, then 8 minus 7 is 1. Both sides are equal, right? So since both sides are equal, they are both 1 and 1. This is 1, this is 1. So which means A is the answer. So we go for A, right? So you shade A. This is the answer. This is the solution to this question. There is no need solving. Some persons will open brackets and start solving. And when you do that, before you know it, the time for JAMB is over. And may your case not be like that in Jesus' name. And if you are a Muslim, inshallah, your case will not be like that, okay? You are going to definitely finish one time and you are going to have no problem. So thank you very much for being here. This is trick number 3. If you are not subscribed and you're watching me, just smash that subscribe button so that JAMB will always notify you whenever I bring up topics like this. Okay, these topics can be very, very inspiring, okay, and insightful, just to ensure that at the end of the day, nobody comes back to repeat JAMB again. This will be the end of your attempt to write JAMB. Okay, I wish you success in your JAMB examination. Now, we move straight to the next question. Remember, it is the plugin method. I told you the plugin method works smoothly for any algebra. Okay, as long as there is solution, bring the solution. Don't look for solutions. Okay, so the solution is already there, but just test and see if it is the actual solution. So we go to the next one, quadratic equation. We are still in quadratic equation. After that, we'll go to linear and fractional equation. So let's take the next one quickly. That's question number 7. We are going to handle question number 7. So I'm going to give you this. Look at this. At what real values of x do the curves, which equations are this and this, intersect? Somebody is going to answer this one now. Okay, I want to make sure that somebody answers this. Yeah, okay. At what real values of x? Look at this. This is question number 7. At what real values? At what real values? At what real value of x? At what real values of x do the curves? What are the curves? Okay, do the curves whose equations are what are the equations? One is y equals to x raised to power 3 plus x, and you can see sometimes it can be long, but the solutions is very light. Solutions are always very light. X squared plus 1 intersect. So this is question mark. Yes, we are going to use the plugin method to solve this. Okay, the plugin method is what we are going to use to solve this particular one too. We are asked here that at what real values of x, okay, or values of x do the curves whose equations are y equals x raised to power 3 plus x and y equals x squared plus 1 intersect. So at what values do these intersect? Very, very easy peasy. Don't solve. Somebody is saying, okay, we equate this. Yes. Then we'll start finding the values. The answers are already in the objective question. Just bring the answer, plug it in. If the value for y here is equal to the value of y here, then you have gotten your answer. So just look at the answers, the options. A, we are given -2. B, we are given 2. C, we are given -1. And D, we are given 0. Remember, I told you to always start from the smallest. Don't always start from the bigger ones. Start from the smallest. 0. If you put 0 and they are not equal, try -1, all this minus. Okay? Yes, try -1. Those smaller ones. You can always start from -1. Okay, which is very small. Your 0 is very easy because when you put 0, you can figure it out, right? So it doesn't waste time. Solution. Let's look at the solution to this question. So who can give us the solution to this question? Who have solved it? I know that those of you looking at me or watching this video are scholars. Yes. Thumbs up to all of you because I know you are scholars. All right. So give me the answer now. I challenge you. Give me the answer. All right. So I want you to find a way to provide answer to this question. So I'm waiting. I'm just giving you 30 seconds. Yes, because I am JAMB. I want to give you this question. Yes. So let's see. What is the solution to this question? Yes, somebody say thank you. Oh, I appreciate you. That's Oku Dili. Oh, Oku Dili Victory. Thank you very much, Oku Dili Victory. I appreciate you a lot. Yes, you said thank you. Thank you too, and God bless you. Oku Dili Victory. Yes, I'm convinced. Thank you very much. Yes. Please, Oku Dili, I hope you have subscribed. Please do hit to smash the subscribe button because AZ Science TV is committed to making sure that you enjoy mathematics. That's why we are here. Okay, if we are not here for you, who else are we here for? That's how it is. Okay, now it's time to provide solution, right? Because that's why we are here. Now let's look at it. At what three values of x do the curves whose equations are y equals x over 3 plus x and y equals x squared plus 1 intersect? Yes, Okudili Victory. Thank you very much. Now we want to find the solution. Okay, and every other person, please, you have to, if you want me to really know you, please, I want you to show in the comment section. I really want to appreciate you. Okay, all of you watching. Some of you have not sent any chat. Please, I want to really appreciate every one of you. No, so we are going. This is what we are going to do. We are using -2 and 2 and -1, and so don't start from here because it is. Start from these smaller ones, the minus or 0. You can start from 0. 0 is the best number to start with because 0 is the null method. Okay, it brings in the null method, the vanishing method, the hibernation method. 0 will bring it. So let's go. What do we have? We have two equations, right? We have y equals x squared plus 1. That is for this, right? Then we also have this. We have y equals to x raised by 3 plus x. Bring in 0. Let's see. Let's test 0. Bring in 0. So here, y is going to give us 0 squared plus 1. What is 0 squared? Is 0, right? That is 0 plus 1. So what is the final answer? 1. We have used 0 here, right? Let's use 0 here and see if we are going to get 1. Are we going to get 1? Let's go now. Yeah, 0 raised by 3 plus 0. What is it going to give us? 0 plus 0. And that is equal to what? 0. This is 1 and this is 0. So there will be no intersection between these if they are not equal. They must be equal so that they can cross each other. Intersection means cross each other. Okay, let's say two curves like this crossing each other. So they must be equal here. They must have the same number. Either 1, 2, 3, 4, or even 0. But we can see that they are not equal. Okay, so we are going to clean it. Try another number. So let's try another number. So since we have tried 0, it didn't work. We'll try -1, which is close to 0. Remember, our y is equal to x raised by 3 plus x. So let's try -1. Let's try this one. So this is not the answer. This is wrong. Okay, it's wrong. So let's try -1. Try -1. Put -1 here. We have -1 square. Okay, because it is squared. Then plus 1 here. Then do the same here. Y equals -1 raised by 3. Then plus -1, right? I hope we got how we got that plus. Do you understand how we got the plus? Please, if you don't understand, let me know, okay? So -1 squared, this is squared. So the minus disappears, leaving us with 1. Then plus 1. You get it? 1 plus 1. And that is 2 here, right? Are we going to get 2 here? Let's try. This is -1. Remember, this is an odd exponent. Even exponent, we change minus to plus. Okay? We change it to plus for even exponent. But if the exponent is numbers like 1, like 3, like 5, like 7, the minus will remain as minus. Okay? That's -1. Then this minus times plus. Minus times plus is -1. And the answer is -2. You notice that, you can see what's happening here, right? So what happens? It means that this is not the solution, right? So if this is not the solution, we go, because this is 2 and this is -2. Please, that is not the solution. Now that we are done, let's use another negative, minus 2. So let's go to minus 2 now. So we are going to use minus 2. This one will be very fast in the exam hall because you are not teaching anybody, all right? So let's use minus 2 now. Let's use this one, which is minus 2. Use minus 2. Y is equals to minus 2 square plus 1. Then bring it here too. Y is equals to minus 2 cube minus 2. So minus 2 square is going to be 4. Okay, minus 2 square will be 4. Then minus 2 square is 4. Then plus 1. Is that not so? So 2 square is already 4 plus 1. That's 5, right? Yeah, this is 5. Then what about here? Minus 2 raised by 3 is what? Is 8. Minus 8. Yeah, this is 5. This is minus, yeah, minus 8. Okay, this is minus 2. That's minus 8. Am I right? So, and this is minus 2. That's minus 10. Why this one is giving us 2 square? So, which means this is not the answer, right? This is not the answer. So we try the other one too. We try 2. Let's try 2 and see. Yeah, if we try 2, 2 square is 4 plus 1, that's 5. 2 square here is 8. 2 square here is 8 plus. So you can see that the answer is not here. Okay? So with our trial and error method, we cannot find the answer right here. So we are likely to give the answer no answer. Do you understand? So no answer. If you find something like this, it means you are not to answer it. But this is the trick, is the plug-in method. Both of them must be equal. Normally it's going to be equal and nobody can beat it. Okay, that is the solution. Okay, but if you have any reservation, let me know, because I always believe in reservations. So any reservation, let us know. Okay, yes, I'm waiting. Yes, we have tried 0, it didn't work. We have tried 2, it didn't work. We have tried minus 1. Minus 1, it didn't work. Yes, because we use minus 1 here. Minus 1 here will give us 1 plus 1, which is 2. Okay, then minus 1 here will give us minus 1. Okay, minus 1 minus 1, which is minus 2. Then minus 2 will give us here 4 plus 1, that's 5. All right, then minus 2 will give us minus 8 here. Minus 8 here. Then minus 2. Minus 8 minus 2 is minus 10. So all of them didn't work. Then we try 0.
Yes. I'm sure you can hear me now. Can you hear me, please? Can anyone hear me? Can you hear me now? Please, sorry for that. I apologize. Please, if you can hear me, let me know in the comment section. Can you hear me, please? Can you hear me now? Please, if you can hear me, let me know in the comment section. Yes, some of you could not hear me. Please, I want to know if you can hear me. Sorry for not being able to hear me. Please, I want to know if you can hear me. But if you can't hear me, I will only be talking to myself. All right? I'll be talking to myself alone. Sorry, the speaker actually went off. Yes, because the battery went down. I hope you can hear me. Please put it in the comment section. I want to put it in the live chat. Okay, I want to know if you can hear me. Okay, yes, we can. Oh, thank you very much, Uncle Delivery. I appreciate you a lot for saying this, for a response. Thank you, and I apologize for that again. Okay, that's why we usually have 2 or 3 of these speakers so that we don't have issues while online. But sometimes things like this happen. So thank you very much for this. Please, as I was saying, I think most of you didn't hear me. You said if the quadratic function, if this quadratic function is a perfect square, if it's a perfect square, find R. Okay, find R. So what is R? R is that letter C, which when placed here will make this expression a perfect square. How do we find R? Very simple. Okay, so we find R using the discriminant method. If D is equal to 0, then the quadratic equation will be what? Will be a perfect square. All right. Discriminant is that quantity inside the almighty formula. What's called the almighty formula, or the general quadratic formula. That's what we call it. So there are different names for it. I don't know what you call it in your own area. If you have a name for it, put it in live chat. Let me still learn from you. Okay, we are all learning from each other. Yes, the fact I'm here is just because I'm just opportunity to be here. Tomorrow I could be watching your own view too. I could be watching your own video as well. Okay, so the question here is that what will be added here to make this expression a perfect square? That is the question. So what is the discriminant? If you look at the quadratic formula, this expression is inside the brackets. Okay, this expression is actually inside the brackets, and when this expression is equal to 0, then the quadratic equation or the quadratic expression, it will be a perfect square. That's the implication. All right, so this is D. D is equal to b squared minus 4ac, and it is known as the discriminant D. So this is the method we are going to use. We are not using the other method where we are told to divide by 3, then take half of the coefficient of x, then square it. It may not be necessary for that. But if you think so, it's okay. But if you can use this, it's simple. So what is our b? Our b is minus 7. So we can have our minus 7, square it. Remember to square everything. Don't square only minus 7. Don't square only 7. Square minus 7. Then minus 4 times a. What's our a? Our a is 3. So just put your 3 here. What's our c? Our c is r. And everything is equal to what? 0. That's the implication. So what is, yes, what is minus 7 square? If you square minus 7, you get 49, right? That's 49. 49 minus 4 times 3 is 12. That's 12r is equal to what? 0. 12r is equal to 0. Please, if you can see it very well, let me know, okay? I hope everything is going on well here. So go ahead, transfer one of them to the other side. This minus becomes plus, right? Yes, which means we have 49 equals to 12r. Because when this one goes this way, when it moves this way, it becomes plus. So the minus disappears. We can divide both sides by 12, right? So if you divide both sides by 12, what do we get at the end of the day? We have r will be 49, right? Divided by 12. This is the solution to the question. Yeah, yes, well, 4 times 3 is